hope everybody's ready to go ahead with today's lesson. We are actually on lesson 4 of 6, and we're doing Euclidean geometry, and today we're doing quadrilaterals. And now I gave everybody, I just want to see with a thumbs up, except for those of you who are new. Everybody who was here on Monday who's a veteran Watobe, I gave you guys a homework. I said you guys need to go learn the properties of quadrilaterals. Put a thumbs up in the chat if you actually went and did it. And if you didn't, I would know. I don't know how. You don't have to ask me how I know. I just know. Tell me, did you go learn the properties of quadrilaterals? And see you, Rorisang and Temelite. Hello, Owame. Is that Kushe who's also giving me a thumbs up? And Kamo as well. Oh, Stacey even forgot. Stacey just forgot that there was even homework. I was a little. I can't believe it. I cannot believe it. Hi, Akachuko. I hope I said that correctly. Hello, Mila. No, you're not supposed to forget. Look, you can't tell me you're going to forget something and then go and forget it on purpose. No. We can't do that. All right. So some of us actually do know the properties of quadrilaterals. So we're going to put these to the test today. We're going to start with something. This is like, I forgot as soon as I got it. I can't believe you. Disappointment. Disappointment. All right. Bukang is also joining us for the first time. Very welcome, Bukang. You're very, very welcome. All right. So I still do have the properties on the board, on the screen. I have the properties on the screen. So we are going to be referring to them every now and then. But it's very, very important that we understand where these properties are going as we go along. Now, the convention is always going to be that when we are looking at these, we're looking at properties that we already know. So we're going to be looking at what we've been given and what we have and what we know about the quadrilateral and the reasons behind the reason these things are that. Okay, so if we think about the proofs of these quadrilaterals, and I know Muteo's about to be like, yo, I have to prove that a square is a square. Yeah. Unfortunately, we're going to have to prove that a square is a square. Okay, we're looking at the proofs of quadrilaterals. And one thing that I want us to remember is this acronym over here. It looks kind of weird, but it's going to make sense in a little bit. I'm so sorry. All right. It's called cpctc, and it sounds like something weird. It's not. It literally just stands for congruent properties. Congruent properties. Properties of congruent. No, I'm lying. Okay. Or congruent properties of congruent triangles. No, I knew I was lying somewhere. Corresponding properties of congruent triangles are congruent. Sankella's like, it sounds like a deadly virus. It's not. Hello, Camilla, no worries at all. Okay, sure. And Kimotoko, this has been happening often. I'm so sorry to hear that. All right. So it says that corresponding properties of congruent triangles are congruent. So what that means is, if I can prove that certain parts of my parallelograms in the triangles are congruent, and I can prove that the triangles are then congruent, the rest of it is kind of going to fall into place. So when we use cpctc, it's because all the other sides that we've already proven already match up the congruency of a triangle. Okay. Oh, yes. Okay, this makes sense. I get what you're saying. Okay, yes. Okay. Yes, Michael, massage that mental brain matter because we're about to use it. All right. So over here, we've got a parallelogram. Got a parallelogram. They're telling us that it's a parallelogram. And they say to us, decide whether each of the given information alone is sufficient to prove that a quadrilateral ABCD is a parallelogram. Now, when we're looking at the statement, it almost sounds like, ma'am, what are you saying? What are you saying? But we know that there are certain properties of parallelograms that only belong to parallelograms. And that's what, yes, I think that's what she, that's what is going to make a parallelogram a parallelogram. So if we look at this particular question over here, it's saying which one of these by itself is going to tell us that this thing or this shape that we've got is a parallelogram. Let's look at question 1 or statement 1. Statement 1 says that E is the midpoint of AC and BE. Now, E over here is the midpoint of that line, AC, and BD. Now, that tells me that the diagonals of my parallelogram need to meet at E point. They must bisect each other. So they must touch each other at a point. Now, if we look at the properties of parallelograms, when we look at the diagonals, it says here that the diagonals must bisect each other. So if the diagonals bisect each other, that tells me that it's a parallelogram. Right, that tells me that it's a parallelogram. So if we prove that E is a midpoint of AC and BD, yes, in fact, this particular statement will help us prove that that this quadrilateral is a parallelogram. Now, if we look at question 2, let's look at number 2, statement 2. Statement 2 says the angle ABC plus the angle CD. Let's go map out where ABC is. ABC. So they're telling us about this angle over here at B, this angle here. The angle ABC, that's it, and the angle BCD, this angle BCD. So this angle over here are equal to 180 degrees. Now we need to go back and look at the properties of a parallelogram. Let's go have a look. Does the properties of parallelogram tell us anything about the two angles at the bottom of our screen being 180 degrees? Anywhere do we see that kind of property? No, not really. No, it doesn't. And the reason for that is because if this angle over here is 90 degrees and this angle over here is 90 degrees, that also adds up to 180 degrees. Does that mean that my shape is then a parallelogram? No, it's not going to be a parallelogram. It's going to be or a rectangle. Doesn't necessarily have to be a parallelogram. So is this one statement, is this one statement enough? Is it enough to prove that our shape is a parallelogram? No. Now, don't get me wrong, guys. It is true that the angles here, it's very true that they'll add up to 180. But does it mean that that's the only thing we need in order to prove that this thing is a parallelogram? No, it's not enough evidence. It's not enough evidence to tell us that this is a parallelogram. That's okay, patients. That's okay, my sweetie. Remember, we're recording, so whenever you have the time, you can come back. All right. Usha says she can hear me. Can I just double check with you guys? Give me a thumbs up if you can hear me.
Yeah, I asked because Senamida was having an issue.
Oh, okay. All right.
It's on her side.
Well, I've got everybody here who can hear me. I see somebody else saying not really. Who said not really? Kimotoko says not really. Kimotoko, I think it may be your connection problem also, my sweetie. So, and Stacy says they can't hear me. Apple Lico also can't hear me. Somebody named iPhone. I'm gonna need to change your name because iPhone is not. Okay, I'm gonna have to change your name at some point. All right. Novacity says I'm breaking and okay, can't hear properly. All right. I'm wondering if it is the sound on my side. My volume is turned all the way up and I'm speaking with a very high, like a loud voice. So I'm not 100% sure where this is coming from. Teacher Nels, can you just ask everybody who's having an issue just to quickly leave the class and come straight back in? Okay. Let's just pop that in the chat and see if that'll help. All right, guys. While all of that is happening, that's true. That's true, Stacey. That's true. All right. Let's look at this part over here. Let's look at number 3. Is this enough? Is this enough information for us to say that this thing is a parallelogram? It says here, line AB is parallel to line CD. So they're telling me that these two are parallel, right? And they're saying that line BC is congruent, but what they mean by congruent is actually equal. Okay, it's just the convention around the world, whether you say congruent or equal. Most places will say congruent. It means equal because we know that anything congruent means that they're exactly the same. Now it says line BC is exactly congruent to DA. So these two are exactly equal to each other. Now, if we look at the properties of the parallelogram, without even going up, do you guys think that the information they've given us here is enough to prove that we have a parallelogram? Yes or no? Let's think about it. What do we need from a parallelogram? Pucha, you mustn't just say no. You must think about it first. Okay, Raboka, and if you say no, you need to tell me why. Amrita says yes. Okay, Nicole says, please repeat the question. Absolutely. Nicole, if you look at the information they've given us over here, is this enough information for us to prove that a shape is a parallelogram? That these two sides are parallel and that these two sides are equal. Is that enough information? Absolutely, it's enough information. Because not every shape, like for instance, what's it called? The ugly one, the trapezium isn't going to have that kind of information. People, welcome. Yes, absolutely. This is going to be enough information because when we look at the parallel lines, here's what's going to happen. We can split this into a triangle and we can split this into a triangle. And the information that we've been given over here on the inside is going to be enough to prove that the two triangles separately are congruent. Therefore, the shape will be a parallelogram. So absolutely, that's going to be enough. Okay, so this one is going to be enough. All right, now let's look at the next one. It says, the angle ABC, so ABC, so we're looking at this angle over here, and is congruent to the angle ABC, ABC. So those two angles are equal. And also they're saying that the angle BAD, so BAD, over here, is equal to triangle, is equal to angle BCD, BC, so on. What do you guys think? Yes or no? Enough information for us to prove that it's a parallelogram? Think about what we know. Absolutely, Real Yes, 100%. If we look at the properties of a parallelogram, it says here, two opposing pairs of equal angles. So opposite, it's supposed to say opposite. I don't know why it's saying opposing. It's not opposing, they are opposing. Yes, it's enough information. So it doesn't necessarily have to be 90 degrees. It could be like 60 and 60 and 30 and 30 and far-fetched. But yes, that's enough information. So this one is going to help us. Okay, this one is going to be enough. Number 4 is going to be enough. Now let's look at what they say over here. Let's look at the next one. It says, triangle ABE. I'm going to go map out our triangles. Triangle ABE, triangle, is congruent to triangle DCE. Is congruent to triangle DCE. Yeah. What do we see? What do we see? And I'm going to just show you guys quickly that they haven't told us anything about any of the other sides. But what we know specifically about congruent triangles, we know that side AB will be equal to which side? If they are congruent, which side will AB be equal to in my other triangle? Because they're congruent. No, that's it. AB will be equal to DC because they're congruent. So AB will be equal to DC. Now let's go to the other side. Side BE will be equal to which side? BE is equal to Muteo, wonderful, Nicole Puseleto, na, side CE. So we know that E is equal to CE. Okay. Ooh, wait. We might be running into a little bit of a problem here. Okay, but let's see. Let's see if this will actually help. And then it says AE is equal to DE. Those two will be equal to each other. So AE, 1, 2, 3, must be equal to DE. Now, if I'm looking at the way that my my triangle is mapped out, will this be a parallelogram? Michael says yes. Imuduku says no. Muteo says yes. The Slate Queen has arrived. I see it. I see her. Hi, Kama. Okay, I'm getting a lot of conflicting ideas. Some people are saying yes. Some people are saying no. Okay, Michael says all sides are unequal. No, they are equal. There are sides that are equal to each other. Now, remember, guys, let's go back. Let's go back a second. Let's go back a second. And let's look at what this statement said to us. Here, where it said E is the midpoint of AC and B. Now, if AC is if E is the midpoint of AC, what that's actually telling me is that AE must be equal to EC. And if if E is the midpoint of BD, what that's telling me is that BE must be equal to ED. But now when I look at this, what happens to my equal sides? Are they actually equal to each other? No, they're not. They've actually switched them around. No, they're not. They've switched them around. So if we think about what they've done with these two triangles, can they actually help us to prove that this shape is a not a quadrilateral, a parallelogram? Okay. That's it, Michael, you're onto something. In this case, the sides that should be equal to each other are on the wrong side. They're on the wrong side, according to this first statement. So can number 5 actually help us? Can it prove on its own that the parallelogram? No, it can. No, it can. Because the sides have been swapped, and we cannot have the sides being swapped like that. It needed to be the other way around. Okay. All right. I hope you guys are getting where I'm going with this exercise. I need you guys to be very familiar with the kinds of things that can prove to us. Okay. Mateo says, ma'am, can you please repeat? Absolutely, I can. Here we know that E is the midpoint of AC. So if AC is my long side and E is the midpoint, that means this side and this side must be equal to each other. Do you agree with me, Mateo? Hello, Kama. Good. How are you doing, Hello.
How are you, ma'am?
I'm good, thank you. How are you, my sweetie?
I'm good. I was just going to ask, are we still doing proofs?
Yes.
And this is still Euclid?
Yes.
Oh, girl, I'm so lost. I am so lost.
Okay. I know
Oh
it is,
my
but
God.
Euclidean geometry is it's normally in grade 10, like I said, it's just popular.
No, like I think it's because I missed like about like 2 classes, and that's like about
Okay.
it.
Well,
But that
you
also
see, you're
wasn't
gonna
on
have
purpose. You know, when you
okay.
become a slay queen, it's kind of difficult to balance academics.
Girl, the balance. Okay, I totally get you, my feeling. But you're gonna have to go watch the video. Like, you know,
Yes,
you can
ma'am,
fast
cool.
forward, make sure you're fast forwarding, watching the important parts, and make sure you get that. Okay,
Yes, ma'am.
excellent.
Thank you
All
so
right,
much.
awesome. Our resident slate queen is in the house. All right. So Mateo, I hope you're with me here. That if E is the midpoint of both of these lines, if it's the midpoint of BD, then BE must be equal to ED. Are we in agreement? We're in agreement that these two must be equal. Now over here, where they say that triangle ABE is congruent to triangle BCE, remember how we were talking about each bit must match. We were talking about how each bit must match. So over here it says that AB, we know that AB must be equal to BC. If I look at my triangle over here, what this is saying is that this side, AB, must be equal to BC. Right. Let's look at the next bit. BE, the last two, must be equal to the last two. BE, I'm going to draw like a little X there. BE must be equal to CE. But hold on, that's not correct. Which side should BE be equal to? BE should be equal to? Which side should BE be equal to, guys? This part here. BE must be equal to which side? That's it. It must be equal to DE. It must be equal to this side, not the side over here. So what they've done over here is the way that they've mapped out this last triangle over here is not correct. Well, technically it is correct, but that means that if we use that, our shape won't even be a parallelogram. So that's why we can't use it, because the two sides that are equal are not the two sides that we need. Okay. Are we in agreement? Can I just get a thumbs up? Is everybody understanding why we can't use number 5? Is everybody with me? Remo, what's up?
Hi, ma'am.
Hello, my sweetie.
I just wanted to ask about the videos that are being recorded. I'm unable to access them, so I just wanted to ask where can I actually access them?
From the website. Okay, so where you went to today's lesson, if you go to the website and you log in with your Watobe details, and you look at today's lesson, scroll down. Right below today's video, all those videos are there. Okay,
Okay, thank you, ma'am.
excellent. Kamuto, what's up?
Ma'am, I'm having difficulties hearing you a lot. Where can I, is there like videos that are recorded, because I cannot hear a thing, or maybe it's the network.
Oh, okay. Yeah, I think my sound is okay. So if you can't hear me, there probably is an issue somewhere there. But maybe you can so try leaving the class and coming back in and see if that solves it. Okay.
I've done it several times and still.
Is it? Can you try maybe looking at a different method of, like, choose a different speaker, different method of output. Okay.
Okay, I'll try.
Excellent. Thank you, my sweetie. Kama, what's up?
Hi, ma'am. Sorry, just to clarify, like I just like want to quickly run through the proof number 5 real quick before we move on. So are we saying that ABE is not what's that, congruent? Is that congruent?
Yes, it's
Okay.
congruent. No, I'm not saying that at all, my sweetie. I'm not saying
It's
that
not
they're not
congruent.
congruent. They don't.
Okay.
they are congruent. So what they're
Oh, they
saying is
are.
ABE is congruent. Yes. And they're also
Yes.
saying that DCE is congruent. But because we know the properties of a quadrilateral, says that
Yeah.
if this is our midpoint, this side and this side must be equal,
Yes.
right? My
Yeah.
two congruent triangles are saying something completely different. Okay.
Mm.
Because these two congruent triangles are telling me that AB must be equal to DC. Yes, you agree? This one
Yes.
and this one must be equal. Now, if you look at what I've written on the screen, if I said to you BE, if you look at BE,
Yes,
just
ma'am.
look at the drawing. Which side should BE be equal to? BE should be equal to?
DE, ma'am. No?
Good. B should be
Is
equal
it?
to DE. Yes, you're correct.
Oh.
Yeah. These two should be equal to each other. You agree with me? Because
Yes,
that's what
ma'am.
midpoint is telling us, that this side is equal to that side. Now, when I look at what's happening here in my congruent triangle, I've colored in the last two letters, BE. So according to my congruent triangle, which sides are actually equal in their triangle? BE
CE, ma'am.
and CE. But that is false because this is CE over here. And that's not
Okay.
the sides that is supposed to be equal
Equal.
in our parallelogram. Do you understand
Oh.
why it doesn't work?
Yes, ma'am,
Okay.
of course.
Does it make
Oh,
sense a little bit?
yes.
Okay. It's gonna make perfect sense in the next one because number 6 is correct and Michael is telling us that. Okay.
Yeah, girl, we are dropping maths this term. No ways. No ways.
No,
Uh-uh.
ma'am. No, ma'am. You're
No,
with
ma'am.
me. You are with me. All right.
Yo.
I'm gonna show you quickly, Kama. Don't go away. Don't go away.
Okay, ma'am.
Let's look at question 6. Question 6 says triangle BABE. So I'm gonna map it out. Here's A, B, E,
And E.
close my
Okay.
triangle. Is congruent to triangle CDE. CDE.
Yeah.
I'm lying. Other way around. CDE. Other way around. From C to D to E.
To E.
Very close triangle. Now, follow with me. AB.
Yes.
If I choose the first two letters here, AB must be equal to which side in the other triangle?
CD or DC.
AB must be equal to CD or DC. Good. So AB and CD are equal. In agreement.
Yes, ma'am.
Okay. Now, BE, which side must BE be equal to according to the other triangle?
DE.
Yes, it must be equal to DE because I've colored the last two. These last two must also be equal. So this
Yes,
is telling
ma'am.
me that BE must be equal to E. Right?
Mm-hmm.
You're with me.
Yes.
Then we can go
Yeah, yeah.
first and last. AE must be equal to which one?
CE, ma'am.
To
CE.
E. Let's see if that's true. Let's see if that's true. AE, I'm going to put a little X. AE must be equal to CE. According to our midpoint theorem, or this part that says this is a midpoint, this is in fact correct because we did say, comma, that EE must be equal to which side?
DE, sorry.
That's EE. And now this one proves that yes, if we can prove that these two triangles are similar, or not similar, congruent, then
Congruent,
this
yes,
last
ma'am.
proof will tell us that this is actually a parallelogram. So we're going to accept.
Okay.
Seeing what
Oh.
the congruency means to do. Okay. Is it making a little bit more sense?
Yes, ma'am, it's not so bad. I was panicking. I
Not at
really
all.
was. I'm not gonna lie.
Not at
Yo, girl.
Not at all. Very, very easy. We just need to make sure that we're keeping up with it.
Yes, ma'am.
Okay. We're going to show you, we're going to do an example together as a class, and then I'll show you how to put it together.
Thank
All
you
right.
so much, ma'am.
You're very welcome. All right. So this part that we've just done, very important, guys, because we're about to use these kinds of proofs to get there. All right. So let's have a look at what they're telling us over here. This first proof says Yes, Mateo, a little bit. Yes, I understand. I'm sorry, Mercy. Right. It says here that we are given that AB is congruent or equal to CD, and that angle CAB is equal to angle ACD. Now, we prove that ABCD is a parallelogram. What I'm going to do is I'm going to do something that we used to do in grade 7 and 8 statement. We're going to split this thing up into statement and reason. Now, here's what we're going to do. We're going to write down what they've given us. They told us that AB is congruent or equal to side CB, right? So that's the first thing they've given us, number one. They've told us that AB is congruent to, I'm not going to draw that little line on the top because we know what it means. AB is congruent to CD. This is given information. They've given this to us. Right. Then they say CAB, so we need to map that out to see which angle it is. CAB, this angle over here. C to A to B, this angle over here is congruent, equal to ACD. It's equal to this one over here. So this angle and that angle are right. So now this number 2. Angle CAB, and I'm going to put a little copy for the angle, is congruent or equal to angle ACD. That's also given. Now, what we're going to do, guys, is we're going to treat these two as two different triangles. We're going to look at the triangle ABC and the triangle CAD, other way around, actually. Okay. No, I'm lying. CDF. Triangle CDA. Then it says, please repeat number 2. Okay. Renele, here's what it says. It says angle CAB. Normally when they write this, when they write CAB, what they're actually saying is the angle A. But the angle A that is made by sides C and B. So there's C and there is B. And the angle in between the two of them, CA and B, is this angle. Okay. That's what they're giving us. All right. So they're saying that that angle is equal to angle, again, C in between A and D. So we're going to go to C over there in between A and D. Where do A and D meet? Up here. So this is the angle that they're talking about. Okay. So that's basically what they're saying. So now what I'm going to do, guys, is because I can see that this side AB and the angle A belong to this part of my triangle, and this side CD and this angle C belong to this side of my triangle, right? We can almost treat these as congruent triangles. Okay. Good, okay. Okay, Sinesipo saying, can we use the fact that there's alternate? No. If you try and say that, what you're actually saying is that they've already told us that they are parallel, and they haven't done that. They haven't done that. All right, so I'm going to write here, number 3. I'm going to split this into triangles. They've done it for me. I'm going to go in triangle. Okay, let's map out the first triangle. BAC in triangle BAC and triangle. Now I started at B, so I'm going to go DCA, triangle DCA. We know that in this triangle, the given things are true, right? We know that in this first triangle, in BAC, EA is equal to DC. We also know that the angle A is equal to the angle C. Can anybody see anything else on the screen that is in there that's going to help us to finish off this proof? Okay, Matrebe says, I'm a little lost there. Okay. The statement reason thing is taking up a lot of my space and I need it. All right. Statement. Okay. Number one, number two. Okay, for those of you who are confused, okay. All right, I'm going to repeat one bit just so we can get an idea. All right, for those of you who are saying number one and number two is confusing, okay. For number one and number two, guys, I'm not doing anything new. They've given me this information. They told me that AB is equal to CD. That's what I wrote down. I said AB is equal to CD because they gave it to me. My reason is that it's given, right? It's been given to me. Yeah, they said that AB, this side over here, is equal to CD. It's equal to this. They've given that to me. They've already told me that it's there. Now, the second bit of information they've given me, they're saying angle A is equal to angle C. Okay, we cannot use alternate angles because they didn't tell us that the angles are parallel or the sides are parallel. They didn't tell us that. So now they're saying that angle A in between C and B is equal to angle C in between A and D. So angle A in between C and B is going to be this one. And angle C in between A and C is going to be this one, between A and D. Can I just get a thumbs up? Is everybody understanding what I mean when I say these two things? They've given them to me. CAB is equal to ACD. This is given information. This isn't anything new. They've given it to me. Okay, they've given all of this information to me. I didn't do anything new. So now, what I'm going to do, guys, is I'm going to look at these two triangles, right? I'm going to look at the two triangles that make up. Okay, let me just see. Aiden is saying, but A and C on the information doesn't have that thing at the top. Yes, Aiden, that's because of convention. Okay. It just means that this is actually from an American paper. In America, they write the line at the top to show that it's a line. In South Africa, we don't have to do that. Okay, we don't have to do that. Same with the way that I've written my angle. In America, they write angle CAB. In South Africa, we write the little capital over the letter that we want angle to. Okay, so it's just a matter of how you write. It has nothing to do with the sum at all. Okay, I hope that makes sense. Okay, great. Now, remember, guys, we've been learning about congruent triangles. Now, if I ask you to prove to me that this triangle, that this one, this triangle over here, if I ask you to prove to me that that triangle and this triangle are congruent, we would have to find 3 reasons. Are we in agreement? We would have to find 3 reasons. I've already got 1 and 2. What is my 3rd reason to prove that this is congruent? Can anyone see it? I'll give you a hint. It has something to do with where my highlighters went past. Yes, Mawande. Mwah. Kiss and a hug, 100%. And you even get a lollipop and a chocolate. Okay. Michael, they're not parallel. They didn't tell us that they're parallel. What Mawanda is saying is that AC is common. AC is common. Not that A is equal to C. AC is a common line in both of them. Okay. AC is common. Okay. Okay. But I can't just say, guys, I can't just write that AC is common. I can't do that. Because what do I mean AC is common? That doesn't make any sense. Why is AC common? So rather than just writing that AC is common, I need to start by stating which triangles we're going to find this from. So now I go in triangle, and I'm going to map it out. BAC in triangle BAC and triangle. Now remember, I need to do the same thing. I need to do the same thing on both sides. BCE. It must be the same. Triangle BCE. Okay. DCE, not A, who said? DCE. Only then can I say that AC is common. And my reason here is the properties of congruent triangles. Properties of, excuse me, of congruent. Okay. Now that I have these three things, I know that this is common, right? I know that this is a common line, which means that it's a diagonal. It's a diagonal, guys. It goes from AC and it's a diagonal. Now, we always know that our parallelograms will have a diagonal, right? What is the diagonal? Yo, look at me, I'm even lying to people. Yes, it's a diagonal, but it doesn't prove anything at the moment. Somebody did actually say it. They said that here, there is an angle. There's an angle over here.
Oh, ma'am.
Angle and this angle. What do we call these two angles over here, guys? Yes, Tabang.
They are called on vert opposite angles, ma'am.
Good. Yes, that's it. They are vertically opposite.
Ma'am,
Okay. Yes, sir. Yes, ma'am. Sorry.
did you see Renetta's comment about, number 3, when you said angle BAC and angle, triangle DCE? Isn't it supposed to be DCA?
DCA, yes, absolutely. It should be DCA. I'm so sorry. Yes, and that's a big mistake. I shouldn't be doing that. Yes. Okay. All right. Okay. It's triangle DCA. Thank you for that. Thank you for that. All right. Now we know.
BAC. Sorry.
Yeah, no, it needs to be DCA because of the way that I mapped the other one around. Okay.
Yeah.
So if we look at here, this angle and this angle are going to be equal to each other. Now that I'm looking. Yeah, it's not going to help us. The only thing we can use is the fact that DC is common. Now, if we have these three things, we can then say, yes, properties of congruent triangle. Right. Then the fourth statement that we're going to make here, right? If that is common. If we've proven that AC is common and that these three things or these two things make those common, we can therefore say that triangle BCA is congruent triangle BAC. Yeah, teacher Coco. Triangle BAC. Triangle BAC is congruent to triangle BC. Now, what is my reason, by the way? What is my reason? What is my reason for congruency here? Is it SSS? Is it ASA? What is it? Okay, Moteo, you are 100% correct. We've got two sides and an angle in between. Therefore, it is SAS. Okay, yes, Remo.
Ma'am, I wanted to ask about the quadrilaterals. There is a question that
Yes.
I got where they were asking me. I was given questions. My question was, a quadrilateral ABC is a parallelogram, and then they say if, and then they give me statements to below for me to prove. So I just wanted to ask if you're going to be doing that or not.
That's exactly what you're watching me do.
Okay.
That's exactly what it is gonna be. Okay.
Okay.
All right. Stephen says, please explain why. Yes, Stephen, because there's a side and an angle and the side, and the angle is in between them. That is why we have angle in between the two sides. Okay, that's why we call it ECS. Okay. Ooh, girl, don't tell me about drinking. I even feel bad, guys. Imagine it's 7:55 and we've only done one question. So you can imagine where I'm at. All right, so we know that this is side angle side. Wow. As soon as we've proven congruency, guys, I can then use the properties of these two congruent triangles to prove the other side. I can say that side BC, which side does side BC need to be equal to? I'm going to write number 5 over here. BC needs to be equal to which other side? Good. To side A. Okay. BC needs to be equal to BA. Just going to scroll over to the side. The reason for this is that long thing that I told you to memorize. C, P, C, T. Congruent or the corresponding properties of congruent triangles are congruent. That means that if this triangle is congruent to this triangle, then all the other sides will be equal to each other. That means that this side will be equal to this. Okay, and this side is common. I can say that. I can also go again, I can go ahead again and talk about how this angle will be equal to this angle. Because congruent side or congruent properties or corresponding properties of congruent triangles are congruent. We can go ahead and go. Number 6, angle ABC, angle ABC is equal to angle ADC, is equal to angle ADC. And the reason for that is the corresponding properties of congruent triangles. Okay. Now, if we look at the properties of a parallelogram, we know that the opposite angles must be equal. We know that the opposite sides must be equal. That's enough information for us. That is enough information for us to then say that ABCD, therefore ABCD is a parallelogram. Okay, it's a parallelogram. And the reason for this is you can use just about any property in this case. We can say that opposite angles are equal. And opposite angles of a parallelogram are equal. Okay. Opposite angles of are equal.